I want to make a video that will help you work through some difficult problems, but will not be me solving these problems. So I'll be trying to solve problems that are similar to the problems that you have. Here on assignment one, problem 11, well, currently it's problem 11. You've got this problem with three people that are getting onto an elevator and they have some number of floors to choose from. So here, it's called the elevator problem. You've got three people or four people or whatever, however many people you've got. It's kind of like number of dice. It's kind of like, if I'm still using the same notes, four people who are getting off on bus stops, how many options they have, or when you roll dice, how many options that there are for each dice. In this particular case, it's like the number of people, which is three, and then the number of floors, which might vary from version to version. So this kind of problem is very similar. Here's the real setup. You've got some number of people, and they all have the same number of options. So just like a die has six options, or people on a bus have five stops, or in this case, the number of people on the elevator and how many floors they have as options to choose. So here I'm going to, instead of talking about elevators and floors that they could stop on, I'm going to talk about people and how many bus stops they could come off of. So here, if I have four people on the bus and there are five stops that the bus will make, how many different combinations of people getting off at various stops are possible. So the way that I thought about it is, here's person one. I don't know who they are. Say they're Bob and Sue and Jesse, who knows, whatever. So you've got four different people, and then here are the number of options that they have. Bob has five options, so does Sue, so does the next person, so does the next person. So here, if Bob gets off at one, it doesn't change what Sue can do. Sue still has all five as options. So I've got five times five times five times five, which is five to the fourth power, or 625. Then, if we're trying to talk about what's the probability that they all get off on a particular stop, okay, so in this case, on the first stop. Well, how many options does Bob have? He only has one option. He has to get off on the particular first stop. So this number is not a one because it's the first stop. It is a one because he only has one option. He has to get off on that particular stop. So that's one times one times one times one, which is 1 to the fourth power. And then here we've seen that the denominator, the total number of possibilities, is 5 to the fourth. So it'd be 1 over 5 to the fourth. Okay, so when you're talking about then all of the passengers getting off on the same stop as each other, that's not a particular spot. It could be either spot one or spot two or spot three or spot four or five or whatever, but they all get off on the same as each other. So there's some ambiguity here. It doesn't really matter which stop they get off on, as long as they get off all on the same stop. And I want to start introducing some higher level techniques here. There are multiple ways to solve this, but I think one way that'll be good is using here something called the multinomial coefficient. Okay, so what I'm saying is that there are five stops to choose from. If all of the people, if all four people are going to get off on the same stop as each other, I don't know which stop it is. I'm just going to call it whatever stop it was stop A instead of one, two, three, or four, or five. So then here, I have all of them getting off on the same. There are four of the same kind. So here I've got a quad, like four of the same letter. So I've got one quad. I've got zero triples. Okay, so here I've got four of the same kind, but not any other letters. I don't have any triples. I don't have any doubles. I don't have any single letters. And then here in the multinomial coefficient, you need all of the options in sort of the second part here, this 1, 0, 0, 0, and 4, you need them to all add up to how many there are. So here, I just put in a 4 because I only had a 1 and I needed to add up to my total. Okay, so that is here selecting the the arbitrary stop they get off on. And then for order, I've got out of the four people, all four of them got off on the same place. Okay, so here, then I've got five with the multinomial one. You can include the zeros or not, and as well as four. And then I've got four with the multinomial of four. Okay, so there's two ways that you can uh, tackle a multinomial. Well, I guess three. One is that to calculate a multinomial, whatever's in the top, that's just you do a factorial of that, so that would be 5 factorial. And then here on the bottom, I've got a 1, so that's going to be a 1 factorial. And I also have 4, so that's a 4 factorial. You could also include these 0 factorials, but because 0 factorial just ends up being 1, you don't have to include them. Actually, the same is true with 1 factorial. 0 factorial is 1, and so is 1 factorial. It's also 1, so anytime you're dividing by 1, you don't actually have to include those. And then here, again, using the multinomial coefficient, you've got 4 on the top, so that would be 4 factorial. I've got 4 on the bottom, so that would be 4 factorial on the bottom, and I have a 0 on the bottom, so that's a 0 factorial. Again, you do not have to include 0 factorials or 1 factorials because you're simply just dividing by 1. And so then you can crunch the numbers that way. Another way in this particular case is here you've got 5 with a 1 and a 4. All of these are zeros. So you could say that's, the multinomial of 5 with 1 and 4. When there are only two options, so 1 and 4, you can also convert this into the choose function. You could either say this is 5 choose 1, or you could say it's 5 choose 4. Because there's only two options, really what you're indicating is what is and what isn't. So either way, you will get the right answer. So here, you could convert this as well into 4 choose 4 or into 4 choose 0, which would each equal the same thing. So you can either use your calculator for things like factorials, or you can use some software. So here, if you've downloaded R and RStudio, here I'm working in RStudio, but you need to download R first before downloading RStudio. One function here, I'm in the console window, one function that you can write then is the command choose. Okay, so here, if I wanted to write 5 choose 1, then I could say 5 comma 1. And then here I claimed that 5 choose 1 is the same thing as 5 choose 4. Let's just see if that is correct. And it is. The other thing that you can do in R is you could use factorial. Okay, so you could also say, if you were typing things out sort of longer way, you could say 5 factorial is whatever it is. And then the other thing that you could do is actually use the multinomial coefficient expression. To do this, you're going to have to download and install a package. Once you have RStudio all up, here, let me just make this a little bit bigger. Here in this bottom right window where it's got files, plots, packages, I'm going to click on the packages tab, and then I'm going to install a package. The package that I'm particularly interested in for this multinomial function is called interpc. So I can start typing it and then I can see that it shows up and I can click it. And then here I want to make sure that this checkbox that says install dependencies is selected, and I'm going to install that package. Okay, so it's going to download, and R will download from the internet some information from this package. And then once it's installed, I need to either scroll down in this list of packages, or if I like, I could search for this package that I just downloaded called interpc. And once it's downloaded or installed, I need to also check this box, which means that it'll be loaded and installed. Okay, so if I've installed and loaded this package called interpc, now, but not before now, I've got this command called multi-choose. Okay, so if you try to use the command multi-choose before downloading and installing the interpc package, you will not be able to find this function. And so if I'm trying to choose or if I'm trying to use the multi-choose function, then here, if I want to calculate here this multi-coefficient, then sorry, if I want to calculate this command here, then what I need to do is I don't need to actually worry about the number on the top, just the numbers on the bottom. Okay, so here, if I use the multi-choose command, inside of the brackets, I'm going to put C with a double open and a close bracket, and then I'm going to put here the numbers 1, then 0, then 0, then 0, then 4. So 1, 0, 0, 0, 4. And if I press enter, it will tell me what what the answer to that is. So you could have also said like it really doesn't matter if you include the zeros or not, but what does matter is here this list in the bottom needs to add up to be what's in the top. So here you can see because 4 plus 1 is 5, then it will be calculating the right function. Okay, so anyways, and then the other thing I guess that we can do is find out what the denominator is, which was 5 to the power 4. So then here, the probability that all 4 people will get off on the same stop as each other is just going to be here 5 times 1 divided by 5 to the 4th power. Okay, so that's going to be 5 over 5 to the 4th power, or 1 over 5 to the 3rd power. Okay, if you want to go on and say, well, what's the probability that exactly 3 out of the 4 get off on the same bus stop? Then imagine that 3 out of the 4 people are getting off on bus stop A. Again, I don't care which one it is, whether it's 1, 2, 3, 4, or the 5th stop, just whatever it is, it's the same as each other. And I guess if 3 are getting off on the same stop, that means 1 is getting off on a different stop. Notice here now I have not a quad, I don't have 4 A's. So here when they're all getting off on the same stop, they're all getting off at the same place. Here I've got 3 people getting off in the same one, and then 1 person getting off at just their own individual stop. So out of the 5 stops, I've got 1 triple. Okay, so here that's 1 group where all are getting off on the same. I've got 1 group that's just a single. I've got 0 doubles, so I don't have any just double reps. And then, of course, because I've got 1 triple and 1 single, I need to add on this 3 because 1 plus 1 only equals 2. So here I said to get to added to 5, I need this to be a 3. And then, of course, we're talking about the order of the people. So it really doesn't matter if it's Bob, Sue, and Frank that get off on the 3, and then, Charlie is the one that doesn't. Or if it's Bob, Sue, and Charlie, and then Frank not getting on the same. Here, I don't care which of the 3 get off on the same. It could be any of the 3. So here, when it comes to order, I've got 4 people in total, and 3 of them are coming off that A, and 1 of them is coming off for that B. I could then find what this term is going to be. It's 5 factorial over 1 factorial over 1 factorial and over 3 factorial. Or you could use this multi-choose command to say here in the bottom section, this is a 1, and a 3. You could also put in the 0 if you like. You don't have to. Notice that you don't have to put the same order in. It could be a 1, 1, 3, or a 3, 1, 1, as long as I have the numbers 1, 1, and 3, which of course add up to 5. It doesn't matter which order I put them in. And here then, this is going to be 20. What about when I want the 4 factorial over 3 factorial and 1 factorial? I can just say here 3 comma 1. So here the bottom line is 3 and 1. I know they add to 4. And so here on the numerator then, I'm going to get a 20 times 4. So here I've got 20 and 20 times 4. So here I've got 20 times 4 divided by the 5 to the 4th power. So the probability that 3 of them get off on the same stop and 1 of them gets off on a stop other than the same and the other 3 is about 12.8%. Okay, continuing on. What's the probability that they all get off on different stops? Okay, so here 1 gets off on either 1, 2, 3, 4, or 5 stop, and they all get off on different stops. So as far as stops go, you can see I've got an A, a B, a C, and a D. I don't know what these stops are, either 1 through 5, whatever, as long as they're different from each other. Out of the 5 stops, I have 4 single letters, whereas here when I had a triple and a single, and up here I had just 1 quad, I now have 4 separate singles. So out of the 5, 4 of them are singles, and then here plus 1 to equal 5. Okay, so I could type that in, multi-choose, and I've got a 4 and a 1. Okay, so this gets me the number 5. And then here for order, again, here out of the 4, 3 of them were on the same and one of them was different. And here out of the 4, all 4 of them were the same. Well, in this case, out of the 4, all of them are different, so it's going to be multi-choose 1, 1, 1, 1. So here, where all of them are individuals and the order really will matter quite a bit. There's no repetition going on there, so here there are 24 different orders and 5 different ways to choose the various stops that need to be selected. So on the numerator then here, this is going to be 5 times 24 divided by 5 to the 4th power, and I get the probability of all the 4 people getting off on different stops when there are 5 stops. It's somewhere around 19.2%. Okay, so what's the probability at least 2 of them get off on the same stop? Okay, so I had to really think about this. If they're all getting off on the same, or if exactly 2 of them are getting off on the same spot, I guess that would be 2 get off on the same and then 2 are singles, or perhaps 2 get off on the same and then the other 2 get off on the same as well. So both of these, AABC and AABB, are both exactly 2 people getting off on the same stop, but this one is 2 people get off on the same stop, and then the other 2 people get off on different stops than the first group, as well as the last person. And this one here is where they both get off on the same, the first 2 people get off on the same uh, stop, and the second 2 people also get off on the same stop as each other, but not as the same stop as the first 2. So that would be exactly 2 people getting off on the same stop. We've already talked about 3 getting off on the same stop and then 1 getting off on a different, and we've also already talked about all 4 of them getting off on the same spot. So here, if I'm talking about at least 2 people getting off on the same spot, then this is the probability that of exactly 2 people getting off the same spot plus the probability of exactly 3 people plus the probability of exactly 4 people. And so using the same ideas here, for the AABC, I've got 5 stops. I've got 1 of them is a double. I've got 2 of them are singles. And then here to add to 5, I need another 2. Out of the 4, you've got 1 group that is the same as each other, that has 2 in it, and then a single and a single. For the A, BB, for some reason I did it over here, then here I've got, out of the 5 different spots, I've got 2 doubles, okay, so an AA and a BB, so that's 2 doubles. I've got 0 singles, and then here, just to add to 5, I need this to be a 3. So 2 plus 5 equals that 3. And then inside here, out of the 4, I've got a grouping of 2 and a grouping of 2. As we've done already previously in this question, if we're trying to talk about a triple, then here out of the 5, I've got 1 triple, 1 single, and then to add to 5, I've got a 3. And out of the group of 4, I'm splitting it into a section of 3 and a section of 1. And then finally, if all of them were to get off on the same stop, that is, out of the 5, there is 1 quad, 0 triples, 0 doubles, 0 singles, and then to add to 5, I've got a 4. And here, out of the 4, I am not separating any of them, then this is a good review, I guess, of how to do any of these particular individual ones. But if I'm talking about at least 2 of them getting off in the same stop, I add them all together. And then, of course, this is out of 5 to the 4th power. The other way to have thought about this is to say, well, if the number of people that are getting off on stops is 2, 3, or 4, so 2, 3, or 4 added up, then 1 minus all different stops would actually get me that. That's the law of complement. So you could also have worked that out. So here I said, to help me out just organizing my thoughts, let X be the number of people who get off on the same stop. What could it have been? We could have 0 people on the same spot, which is the same thing as saying they're all different spots. In this context, saying 1 person be the number of people that got off on the same stop, that doesn't make sense. It doesn't actually exist. And then you've got 2, 3, or 4. So one way of calculating at least 2 was to add exactly 2 plus exactly 3 plus exactly 4 all up. The other way you can see here is if the number of people getting off on the same stop is either two, three, or four, instead of adding these up as I did up here, I could have just said it's one minus what I'm not looking for, which in this case is the probability of people getting off on all different stops. And we found that earlier. So you could find either the answer this way by adding them all up to find that this is the probability, or you could actually try and see that one minus all different stops also gets you the exact same number there. Okay, I realize that this is difficult material. You may want to stop, pause, rewind, rewatch this video, try and work it out, but this time instead of talking about number of people getting off at bus stops, talk about the number of people getting off on floors of elevators. Good luck.